Okay, hello. Okay, hello. Good morning, everyone that's logged on. We will start shortly. I'm going to give it a couple more minutes and we'll go ahead and start our presentation today. Thank you. Okay, good morning, everyone. We're going to go ahead and start our webinar now, slowly get into it in case a couple people start logging on a little bit later. But welcome. Today we are going to cover advanced home irrigation and troubleshooting. And this class was designed to really be an in-person class. I do this class a couple times a year where we have a lot of hands-on components. So I supplemented that with a little bit of videos that I created during this past year. So I hope that kind of helps tie it in. And right now when we start, I'm going to go ahead and launch a poll. If you guys could go ahead and answer the poll questions. Kind of gives me an idea. Unfortunately, I can't see all your beautiful faces. You can't see mine, but I wanted to get to know a little bit of who's in the crowd. So I'm gonna go ahead and launch that now. Now, while we're answering that, I just wanted to go over a little bit of the format for today. So I will be monitoring the chat as well as the question and answers. So if any time during this presentation you have any questions, any comments, please put it in the chat. I have certain areas throughout this presentation where I'll stop and look. I'll see if anybody has any questions, but doing my best to make this kind of interactive because at the end of the day, I'm here for all of you in attendance. And with all of our presentations, a PDF of this PowerPoint you can find at www.cbwcd.org/presentations. And also, I'm live streaming this on YouTube. It is available as all of our workshops are in case you want to go back or if you have to cut out early or anything like that. We're always on demand with our workshops. So we have, I want to say, about 30 plus live stream workshops over the past year. So it's a really great resource. So that's cbwcd.org/YouTube. And those of you that are just popping into this webinar, if you could please do the poll that's posted, kind of gives us a little bit of an idea who's working on this workshop with me today. Just give that a couple more minutes. Okay, I'm going to go ahead and end the poll. So thank you all for doing that with us today. So how many people are watching with you today? So good amount is just me and one other person. So thank you. Typically it's just the one person, but it's always good to know if there's multiple people. Have you participated? So 600% yes. So thank you all for returning. We love having returning participants. Thank you all for continuing to support our programs. San Bernardino County, no, loves Riverside County, so welcome. In the chat, Mount Shasta, well, welcome. From Mount Shasta, I wonder if you could type into the chat where you heard about this. Be pretty interested. A lot from the newsletter. So thank you guys for sending all this information and welcome. And with that, I will go ahead and start. So I haven't done this in a while, so I added this slide just to kind of give a little bit of context to why we're talking about irrigation and how that ties into the big global picture on water conservation. So this is a map. So if you follow on this website, this is the drought monitor. So this covers California, all the different counties. And this was last updated this past Thursday with data from earlier in the week. You can see, we all noticed that we haven't had a lot of rain, but you can see where we're really becoming into extreme drought. Whereas a year ago, during this time, we were more in the maybe a moderate drought, but since we haven't had consecutive years of ample rain and storage, we're starting to see we're really getting into those areas where back in 2015, where we were having a lot of drought conditions. Now we're in extreme drought in the majority of California, where if you're looking, we're kind of right here in this little swoop here in our area, Inland Empire. This is LA County, San Bernardino County. So we're in severe to extreme drought conditions. So I just wanted to kind of preface this workshop and talk a little bit about what we do as an agency, but as a whole, California and other parts of the state, I mean, the other parts of the United States are starting to really see this drought kind of creep up. So it's always good to have that in the back of our minds when we're thinking big picture with water conservation. Which leads us to our organization. So we are the WaterWise Community Center, also known as the Chino Basin Water Conservation District. And we, our main mission is to sustain a regional water supply through public and engaging with the following strategies. So where is our district located? So our district is located in the Inland Empire. We work under the Inland Empire Utility Agency service area. So our facility is located in Montclair. You can see here. And we're part of a bigger Santa Ana River watershed. So our boundary was loosely mapped out in its inception to cover the Chino Basin aquifer area, the Chino groundwater basin area, which is again part of a bigger Santa Ana River watershed. And just a quick, for those of you that are unfamiliar with an aquifer, so an aquifer is a system of water underlined our area where we get up to 50%, a little over 50% of our groundwater comes from our Chino Basin aquifer, where they pull up from wells and is used throughout our system. So going back to our mission, so demonstrate. So we have an 8-acre demonstration garden and park located here in the city of Montclair. Here's a picture of our facility. So these are our large basins we have in the back. For those of you that are local, which quite a few of you were, we just got our llama and goats to help with weed abatement in our large areas in the back to reduce our pesticide use. So those of you wanting to come to the park, and as far as our demonstration garden, I would say within a couple weeks, from what I heard, our demonstration garden will be back open with limited times available. So go to our website to get more information on that. Our next part of our mission is educate. And so this kind of falls under that education. So we teach workshops for the public as well as professionals on transforming urban landscapes. So going back to that drought map, transforming water-thirsty landscapes to a more climate-appropriate, drought-tolerant landscape. Irrigation efficiency, like what we're going to talk about, all tie in to help combating the drought. And sustainability as a whole. Web resources, so we've created a website called Inland Valley Garden Planner, which has about 400 climate-appropriate plants. We're constantly putting more content on here on this website. So if you haven't checked it out, make sure that you check that out. You can make plant list, gives you horticultural preferences for the plants, when to prune, how to water, if they go deciduous, when's their flowering season, as well as a new feature, we're putting plant palettes and little design templates and incorporating those. So if you like butterflies and birds, a pollinator garden, that kind of gives you an idea of what that could look like for your front or backyard with the plants that would be associated with that. And we have 6 different templates to work with. So looking forward, if you're interested in any of that, we have California Native Garden Design workshop coming up. And we always have our landscape basics transformation classes that will cover quite a bit of transforming your landscape. And lastly, percolation. So for the natural environment, so traditionally in our area before it was urbanized, and this goes for all areas, that naturalistic areas, when we have rain, 40% would evaporate, 10% would run off, 25% would infiltrate, shallow infiltration, which is beneficial to the plant material, and then a 25% deep infiltration, which would have that water pass through the soil and get collected in these aquifers. Now in our urban environment, we have a decrease of evaporation. We have a huge increase in runoff. So 55% of that water runs off because of our impermeable driveways, streets, roads, asphalts, everything that's sealing basically that soil level, with only 10% that gets past that goes into shallow infiltration, and only 5% actually gets down into groundwater storage areas. And so if driving around or just noticing on a walk, we see a lot of these channels. And what this is designed to do is to move that urban runoff, that 55% of water that becomes runoff, and it moves it typically to the ocean, in our case here locally. So as a Chino Basin Water Conservation District, we own 8 of these large open pits, most of which were our old gravel pits. We have connected to our facility here is our Montclair number 4. And what these are used for is trapping rainwater for one, but also that runoff. We're also able to take water from the California Water Project, the California State Water Project from Northern California, and have that water imported, filling up these retention basins, and then that water eventually percolates down into our groundwater, into the Chino Basin aquifer, which again, we use for over 50% of our drinking water that we have. So just a quick, when full, we have the capacity in Montclair 3 and 4, over 47.5 million gallons of water can be filled and percolated down into our groundwater. Whereas all of our basins, when full, when we have a good rain, you can see almost roughly 500 million gallons of water. So a little bit of context, a family of 4 needs about 124,000 gallons per year is the typical need for a family of 4. So you can see these large pits fully being at capacity and percolating down into the groundwater really does benefit our local area. And again, working with our community, K through 12, higher education, workshops like what we're doing here. So this is the part where in person, I love to kind of get to know a little bit about everybody, but since we aren't able to do that, I would just give a quick little couple words about myself. So why am I talking to you about irrigation? Well, I've only ever worked in landscaping. My parents have owned or operated a landscape company since I was a small child. So always having to go on the weekends, fix things. And I just kind of fell into it. Started working. And I really got into arboriculture, learning about trees, and then also irrigation. There's a lot of engineering that can go into it. Reading maps, knowing flow rates and velocities of water, piping sizes, and I really got into it. So kind of took over my career path, irrigation. I became an instructor for about 3 years. I used to travel. This was a class I taught in Arizona. I would be up there for a week. I have this big trailer, and we would have all types of irrigation components, controllers, valves, and we would go through about a 6-7 hour day, 5 days for them to get certified on irrigation. So definitely something that I am passionate about, that I've spent a lot of time in the field as well as teaching. And I'm happy that I get to work with all of you on irrigation topics, which leads us to what we're going to talk about today. So a couple weeks back, I did a irrigation basics. So if you did miss that and you're interested, I'm going to kind of breeze over a little bit of those topics. Again, this is a little bit more involved with repairs and maintenance of an irrigation system. So if you go to our YouTube channel on live streams, you can look and find that workshop. But we're going to talk a little bit about the irrigation system. We're going to talk about tools of the trade. A lot of tools. I'm going to cover briefly some of the main tools that are out there. We're going to talk about conducting an irrigation check, have a short video on that. We're going to cover common issues, and then we're going to understand the maintenance that are involved with the different components, if any. Right, so here's some pictures. So one of the programs that we do offer for residential, it's still on hold. We do have a wait list, but we do a landscape evaluation and audit. So we go to a residence, they contact us if they have issues or if they want to know more how they can save water or just want to kind of get a better idea of their outdoor irrigation system and landscape. We have a consultation where we go. So quite a few of all these pictures are from these common issues that we run into. So here we have a picture, it's a sprinkler which was broken, and they have a funny pipe riser. So there's no stability, the sprinkler's on its side. Here's a sprinkler that's probably in not the greatest area. It's watering, basically watering the valves and then a bunch of this ground cover. This was a repair that wasn't done properly, so we're going to cover all those. Kind of give us some ideas. Broken pipes from roots. All this is common because, again, this is an irrigation system that was put in years and years ago. And over time, when being used, these plastic components wear out. So this is all just normal wear and tear. Areas that we see that are overwatered, that are damp, could be a couple issues. Could be an irrigation scheduling issue, or it could be a broken sprinkler issue. But just as an overview, I like to use this. Hunter is a manufacturer of irrigation components. They have this really helpful irrigation layout. So we have the controller, which is considered the brains of our irrigation system. We have our lateral line, our main line piping, our lateral line to the sprinklers piping. We have rotors that cover larger areas, pop-up sprays, valves, water meter, backflow, all of which we'll be talking about. So since this is an irrigation troubleshooting and repair, where do you think on this diagram, where can issues arise? Everywhere, right? We can have issues with our pipes, with our sprinklers, with our controller, with our valves, possibly our water meter. So any component in the irrigation system can fail at a time if proper maintenance or just as father time takes its toll on these irrigation components, we need to address these issues. And we're going to cover all that today. So why should we even care about our irrigation? So everyone here that's logged in have some interest. So thank you again for logging on today. So I wanted to break it down with a little bit of stats. So again, tying in with the idea of the drought and our water supplies, starting to be not in question, but starting to be a little bit pressed. A 3/4 inch PVC pipe, which is the majority of the piping that we have at our residence, at a residential landscape, can flow up to 14 gallons per minute if completely broken. So when your irrigation system is running for 10 minutes, you can see how these gallons kind of start racking up. And that's just for one area. On average, a broken sprinkler can waste up to 9 gallons per minute. Irrigation zone with 10 heads operating at 20 PSI, higher than its ideal operating pressure, can put out an extra 100 gallons of water per week, with the majority of the water being applied, running off the site and down the street. So irrigation systems that have high pressure, will cover how pressure affects a sprinkler system, especially overhead spray that we have pictured here. According to the Irrigation Association, where I got the stats from, if irrigation system is 20% higher than its ideal operating pressure, we're getting a lot of wasted water from misting, which is high pressure water going through our sprinklers, causing a mist. A lot of that water just runs off. So we waste quite a bit of water with high pressure as well. So what I wanted to start with is an irrigation check. So our last workshop, our basics, we ended with this irrigation evaluation because we talked about the components. Now this class is kind of starting after we do an irrigation check and we find some issues. How can we do this? And again, an irrigation check ideally should be done for a home, at a residence, should be done probably quarterly, especially right before the warm season, and then sometime going into winter when we're going to really be dialing back the time of our irrigation system. If we do have some repairs and the irrigation system needs to be off, that's an ideal time to make larger repairs. And then a tune-up going into spring when we're starting to need to water based on the weather. Great times to do it. If you can get out there and do an irrigation check more often, the better. Again, these systems run during the middle of the night or early mornings, where we're typically not out, out there looking as things running. So I'm going to watch this little video about how to perform an irrigation check to kind of give us an idea of how our irrigation system is going.
In this video, we're going to be talking residential irrigation. We're going to cover the 5 steps to completing an irrigation evaluation that you can do at home. Step number 1 is check the water meter. Residential water meters are located at the curbside of the residence. A handy tool to have around is a rag so we can wipe down the faceplate or the odometer of the water meter. The reason why we want to wipe down this odometer is we want to look at the readings. As long as there's no water running inside the residence, we can look at the leak detector as well as the odometer. If we see any movement on that dial, that's indicating that we have a leak. Looks good here. Step 2, walk the landscape area and look for issues. So during our walk, we want to have a notebook handy where we can take notes. I like to indicate the areas doing the irrigation check, the date, and the possible issues. And what we want to look for is areas that seem to be overwatered. Here we found an area that is brown, that is dry, indicating not enough water. Want to make a note of that. And another area we want to really look at is the shrub area. Shrub areas tend to be overwatered, and so we want to really look in and see if there's any areas that we could be saving water. Step 3, locate the irrigation controller. Though not all irrigation controllers are located in the garage, at our site here, that's just the case. They can also be installed on a wall or anywhere that they have power available. Once we locate the irrigation controller, I like to make sure that the date and time are accurate so our program works correctly. There's some other features that we can look at on our irrigation controller, like the start time, when our irrigation is going to start running, how long each zone is going to run, and how often, or how many days our irrigation is going to run for this week. A great thing to do when you run your irrigation system is to write each zone and where they're located in your residence. Once we have that, we know the areas that we want to look at based on our walkthrough. So we have the zone and the area to do it. Step 4, perform a test of the irrigation system. So as we turn on the irrigation system, it's best to give it about 5 to 10 seconds until the zone is completely pressurized. We want to walk around and check for any inefficiencies. We want to repeat that again from zone to zone. So this one here, we seem to have some issues with runoff, as well as a sprinkler that's not only clogged but tilted. Here's an example of a broken rotor. The seal's broken. As well as another sprinkler that's turned and tilted. A pro tip, you can manually turn on your irrigation system at the irrigation valve. By simply turning the bleed screw a quarter to a half a turn, the irrigation system will turn on. This will allow you to walk the site for as long as you need, check out any inefficiencies, and when you're ready to turn the irrigation valve back off, simply come back to the bleed screw, turn the knob till it's tight, and the irrigation valve will turn off. Step number 5, review field notes and make necessary repairs and adjustments. So here are my notes. 3 broken sprinklers. Looks like I have a lot of work to do this weekend.
Okay. So I hope that was helpful. I did fix those sprinklers, by the way, in case you were wondering. It's okay, you can call me out on that. So with that, if there's, I don't see any questions or anything in the chat, so I'm gonna go ahead and move ahead. So now that we know how to do an irrigation check, we are ready to cover tools. So what tools do we want to use, or what do we need to use? And what's the best tools for the right job? Little reference there to one of my shows I watched growing up. So tools of the trade. So trenching shovels. So these are shovels that are sharp, with a pointy tip, and are designed for digging trenches, right? We have different sizes available. So 3-inch is good for detailed work or digging in small spaces. So this is the blue one here on the right. Ideal again for small spaces. I wouldn't dig if I'm running a whole new pipe, or if I'm installing an irrigation system, I wouldn't use this. This is a great tool for doing repairs, especially if you have areas by sidewalks, if you have a lot of hardscape and not a lot of room, or if you are repairing something next to or surrounded by big tree roots. 3-inch shovel, that's the ticket right there. 4-inch shovel is the orange one, kind of the standard 4-inch. You could see a 4-inch on almost any irrigation repair truck. I have one at my residence. This is the one that I have as opposed to the other ones, because it's kind of a universal tool for digging trenches as well as doing repairs. 5-inch is a little bit larger. If you are going to be digging a lot of trenches, let's say you're going to be redoing your backyard and you got to relocate a lot of sprinklers, this would be one to go for. And then they have a 6-inch for digging large areas. This comes in handy. I use it more for planting larger plants. Yeah, so maybe a bigger tree or something like that. But if you had to just get one, the 4-inch is probably the most universal and useful all around. So for digging, so shovels that are ideal for digging, we have a spade shovel. So utility shovel, great for digging, especially rocky soils. Has a big area for you to really get your foot on there, excuse me, and then put some pressure. So for digging, definitely any landscape, if you are going to be tending landscape, spade shovel is a must. A square point shovel, good for hauling big chunks of soil if needed, for shaping, and then also for a lot of detail work on smoothing soil, scooping up. Again, digging, if you're digging, using the square point shovel to move around, load a wheelbarrow, or just move soil around. Definitely a must. And we have picks and axes. So I just wanted to highlight pick Maddox, great for breaking up hard soil situations, especially rocky soil. Helpful when trenching. For an irrigation installation, you can go in and just kind of loosen up the soil, come in with a spade shovel or a trenching shovel and clean out your trenches if you need to trench. Really, really handy tool. I'm going to be doing a lot of work. I got a new property and there's no irrigation at all. And it's about an acre that I'm going to be running irrigation through. So I'm definitely going to be having all of these tools, using all these tools. So if anybody wants to come help me, give me your info in the chat. Just kidding. Okay, tools of the trade, pipe cutters. So pipe cutters are, if you are going to be doing a lot of repairs, pipe cutters do come in handy. I have a pair, but I also do a lot of repairs. So these are called ratcheting PVC cutters. You can get them at a big box store. There's a lot of different brands or a plumbing store, but make sure they're for PVC. And they come in a smaller, which covers a 1/2 inch to 1 inch pipe. So knowing the size of pipe that you're going to be cutting and repairing is essential. So for commercial or larger, 1.25 to 2 inch, there's a larger ratcheting pipe cutter because the opening will not accompany anything on the smaller, will not accompany anything larger than 1 inch pipe. So it won't be able to fit to get the cutting process to start. So typically, again, the smaller residential, the 1/2 inch to 1 inch is going to be applicable. You can cut smaller pipe on the larger cutters, but of course there's a larger price accrued with that. So those are pipe cutters. Other types of pipe cutters, you can use a handsaw. Issues with using a handsaw, you want to make sure you have a flush cut. With a handsaw, it's easier to cut at an angle. When you're making a repair, pipe cut at an angle. When you put your fitting on, your repair fitting, the seal isn't as tight. You could run into issues in the future. So you also need more room when you're using a handsaw. You need to dig a lot more because you got to be able to have that sawing motion. You have to have room to actually be able to use the saw on the pipe. A cheaper option, it is always viable. I have one of those as well. A cable saw. So you can buy these again at any big box store as well. So this is a braided cable with 2 handles. It's kind of like a cheese cutter if you see, if you've used that or seen that. So it's basically the wire, 2 handles. You put that underneath the pipe, pull up in a sawing motion of back and forth, and that'll actually cut. It's only good for, in my experience, like 5 to 7 cuts on one of those cables before they start fraying. Again, depends on the size, but they do come in handy. If you have small spaces, again, limited space, if there's a lot of tree roots or things like that where you can't get your ratcheting cutter in there or you can't get a saw, these cutters really come in handy, the cable saws. And then the last one is a drip tubing cutter. This is not ratcheting. This has a little slot for the drip tubing only. With the blade is not as strong as the PVC cutters. So this is just to cut the drip tubing, and we'll cover drip tubing and the maintenance on that. But I just kind of wanted to throw that in there. Really, really handy tool when dealing and cutting drip. And then hand tools. These are called tongue and groove channel locks. We all call them channel locks. Those are a brand, so they're called tongue and groove pliers, so they can be adjustable. Really, really handy tool for a lot of aspects of irrigation. If I had only a handful of tools. Definitely would have this in my back pocket walking around our landscape. You can use these tongue and groove pliers to adjust sprinklers, to just basically grab a hold of anything, and really handy maintenance tool. Wire strippers with and wire cutters for irrigation valves, as well as any wiring issues. Really essential for doing irrigation maintenance. And then multimeters. I remember when I learned how to use a multimeter for irrigation maintenance, I was really blown away at how useful this tool is for troubleshooting irrigation valves, wiring in the field, and irrigation controllers. And we're going to cover a couple easy ways to really utilize this multimeter to check voltage, resistance, and the implementations of using one of these tools in the landscape. But lastly, and this is a really important tool of the trade, is PPE, personal protective equipment. I'm sure we've all become really familiar with the term PPE over this last year, but it applies to anything that protects you in the situation that's needed. So for landscaping, safety glasses are a must. We want to protect against dirt, debris, and other contaminants getting into our eyes. When we're talking about the gluing process, we definitely don't want to get any of that primer or glue flicked up into our eye, which has happened. Any dirt, debris, when we're using a mattox or we're using a pick and we're at a high velocity hitting our soil, things can tend to come up. So glasses are a must. Work gloves, they protect our hands from wear and tear. We get, if we're digging all day, calluses or anything like that, we want to protect our hands. Work boots, we want to protect our feet and our ankles, especially when we're using shovels, picks, even just walking around our landscape. Most of the times it's a wet surface. We can slip or slide. We want to have a good solid work boot. And then dust masks. So when doing a lot of digging, we want to protect against dirt, debris, other contaminants being breathing those in. So first off, we want to check is with the water meter. So what does the water meter do? So it measures the volume of water used in our home or our business. It's usually owned, operated, and maintained by our water supplier, which is the utility that we pay our bill for. And it measures water volume in cubic feet. In our area, typically cubic feet. So when you get your bill, it'll tell you units is the verbiage. That's 100 cubic feet. So that kind of gives you an idea of the terminology. Again, I'm just covering this really quick. We covered this in our last workshop. So we can actually check for leaks with these water meters. So just really briefly, all water meters are in a box. These are in concrete boxes. This is in front of our site here, but they can be in a plastic irrigation type. I'm starting to see in our local area anyway, but usually it's in a concrete box that's stamped water meter. It's near the road. And a lot of times it's filled with soil, so you want to have a rag handy and possibly a little shovel to kind of clean some of that out to check it out. So how can we check for a leak? So here's different models. So these are the water meter, the face plates. So we have leak detectors on these water meters. So when nothing's running in your house, so you know that the irrigation's not running, you aren't running the dishwasher, you're not doing laundry, nobody's taking a shower, so you know for a fact nobody's using any water in your residence, you want to go and periodically check your water meter. So these different models, so they all have, again, a leak detector. So here it is in the center of the odometer. This is a little blue cog. This one is a little triangle. And what these detect is very low flows. So if we turn something on in our at our residence, the dial would turn. We would see because a large amount of water is being passed through this water meter. However, if it's a little bit of a leak, we're not going to see any movement here, but this low leak indicator picks up those slight movements of water, and you'll see some movement in the leak indicator. So this could be a mainline leak in the irrigation piping or the house piping in your home. It could be a leaky faucet, it could be a leaky toilet, something like that. You would pick up on this leak indicator after watching it for a little while. So that's very, very handy to kind of periodically check and see. If you see your water bill is a little bit higher or a lot higher than the previous month or the previous billing cycle, go ahead and check that out. Really easy thing to do. So for PVC piping, we need to check underground. Right, so is there a problem? So here's a picture of one of the landscape evaluations. This was actually for the homeowners association itself, but there is a broken pipe that was leaking way in the back by the entrance of this home, and it leaked. Again, going to the beginning of the workshop, we talked about how much water, how much volume of water can come out of these pipes when they're broken, and you can see it leaks quite a bit. Here we have an issue where water is just coming up out of the planter bed. Another issue here, so this is when the valve is running, so this isn't constantly under pressure. So when the valve's running, there's a massive leak. This actually was from an evaluation that we did, and I noticed before turning this on, again, this is in the very, very back of the property, but I noticed all this grass growing really, really high in the shrubbery. Weeds can be indicators of overwatering. So this has been leaking for a while. There was actually a tree just out of the picture to the left that rotted and was falling over because it was constantly being soaked, because you could see large volume of water coming out. You know, this was running, I believe, it's been a while, but I believe it was 15 minutes a day, 5 days a week. So you can see that would be a lot of water. And this was during the winter months as well. And sometimes, unfortunately, these breaks do happen under concrete. This was another home evaluation where as soon as we turned on the water for this zone here, water started pouring up from in between. So this is a seam where this is the sidewalk to the left, and to the right was the driveway. And somewhere underneath there, the pipe broke. So massive amounts of water just running down the street. Homeowner was not aware because the road kind of would go down the street, so the water wouldn't stay on his house, it would just run down the street, so he wasn't really aware. So doing those irrigation checks really can open your eyes. You would need to do this repair, you would need a couple more tools than what we covered, maybe a concrete cutter. Sometimes it's best just to abandon, if possible, abandon that valve. Okay, so different types of irrigation pipe and fittings. So we have drip tubing. So I'm going to cover drip towards the end, but it is a form of irrigation pipe. We have the typical PVC fittings with PVC pipe, and then something that I've used for a while, not exclusively, but have worked with jobs, and I am a fan of it. It is called Blue Lock pipe. Availability, I'm not sure because I haven't really bought or used it. I know we at our Waterwise Community Center here, we did a project where we used it, but it's a flexible pipe. It's not PVC. It's polyethylene, I believe. It's more of a flexible pipe, but it acts as a lateral line, so you can't use it as a main line. But after your irrigation valve, it's a more malleable, it's more eco-friendly, and it's a glueless system where the fittings don't need to be glued. They have teeth and they bite onto the pipe, and definitely an option. Again, it's a little bit harder to get all the parts that you need, but how we are all very good at ordering things online now, I would suspect. So it is an option called Blue Lock. So again, glueless system. Yes, so going to PVC pipe. So these are both 3/4 inch pipe. And as you can tell, there's a little bit of difference between the one on the left and the one on the right. Why is that? Well, one is Schedule 40, and the other one is Class 200. So the one on the left, Schedule 40, and the one on the right is Class 200. So Schedule 40 pipe, again, the outside diameter is 3/4 inch, so you can buy the same fittings for both of these pipes, but the wall thickness is different, as you can tell. So Schedule 40, as the pipe gets larger, so this is a 3/4 inch, as the pipe gets larger on a Schedule 40 pipe, the walls get thinner. And what happens when you get larger pipes on Schedule 40, the pressure rating starts to decrease. So the pressure rating for Schedule 40 pipe, 3/4 inch, is over 400 PSI rating, meaning that it can operate at 400 PSI. Our irrigation systems, I really hope that you don't have 400 PSI running through your system. You're going to have a lot more issues than a broken pipe, right? Our irrigation systems need to be running far lower than 100 PSI. So that's the deal with Schedule 40. So once you get up around 2 inches, the wall thickness becomes a lot lighter above a 2-inch PVC pipe. So that's when the pressure rating becomes an issue. Class 200, class is constant. So the pressure rating for a Class 200 is 200 PSI. So regardless of the size, if it's a 1/2 inch PVC pipe, if it's a 3-inch PVC pipe, if it's Class 200, we know that it's rated to operate with 200 PSI as the maximum threshold for the pipe. So issues you do run into with Class 200 pipe in your landscape, it is a cheaper pipe, just right off the top. It is a cheaper option. However, it does become more brittle over time because of the thin walled. So when you're making repairs, sometimes when digging it up, I've hit Class 200 with a shovel and cracked and punctured holes in a Class 200 where Schedule 40 pipe can kind of take that. And then when cutting to make a repair, I've had it where the Class 200 is cracked. So if you do a repair and let's say you didn't install the irrigation system yourself, which I'm sure is probably the case, and you go to do a repair and your pipe seems a lot thinner, it's probably Class 200. Not a big deal. It can be mixed if you want to do repairs with Schedule 40. No need to replace your entire system if you have 200. Just something to be aware of. Thinner walls, but both are actually 3/4 inch on the outside. Okay, so PVC repairs. So I'm going to talk a little bit about PVC primer and priming process and a little bit about the glue. These are things that I wanted to know when I first started doing these kinds of repairs. So what does the PVC primer do? So it strips and softens the PVC pipe and the fittings. It's the first step in the gluing process. We'll cover what that is. Dries really quickly. It's about 10 seconds. So how do we prime? So we apply a coat of primer to the pipe. Inside the caps here, they have a little dauber underneath the lid. So that's how it's like a cotton dauber. That's how you apply to the pipe. And then we want to let it dry, which it dries very quickly. But before we apply the glue, we want to allow that to kind of dry. Again, that's going to soften and strip any coatings, any kind of impurities on the pipe before we start a process. And then we have the PVC pipe cement. So this is the part that actually bonds and holds the fitting on the pipe, or the two ends of the pipe together if you have a bell housing. There's a lot of different manufacturers. There's Christie's, Weldon, OD, just to name a few. All do the same thing. I personally do not have a preference. One thing though I would recommend, if you are going to do some repairs at your home, or if you're going to doing an installation, always opt for the smaller cans of the glue and primer, especially the glue, because the glue will dry over time. So if you don't use it all, when you go to use the can again, you might find that the glue is kind of not as malleable. It's not as liquid. It's starting to kind of harden. I wouldn't use that. And it's wasteful, and it's not really the best thing just to throw in the trash. So using the smaller containers kind of give us a better idea of, or give us a better opportunity to use what we buy. So this pipe cement, it connects pipes and fittings together. Most of the brands, like the Red Hot Blue Glue, they have a quick drying time, so relatively fast. They set within 1.5 hours, half hour to 1.5 hours, meaning the glue kind of set and it will hold together what you put together. You want to wait at least, according to the manufacturers, 1.5 hours before we turn the irrigation system on. However, if possible, I just let it go, let it dry overnight. I've had it where I've glued something, got really eager, needed to go somewhere, turned the system on, and guess what? It kind of popped out, and now I had to redo it and then wait even longer. So always the best option is to wait as long as you can. Again, that's why making repairs, if you have large repairs, or if you want to add sprinklers or do any kind of major renovations during the fall and winter when we don't need the system to run as frequently, is a good idea. So the gluing process: apply a coat of glue to the pipe, coat of glue to the fitting, second coat of glue to the pipe, insert the pipe into the fitting, do a quarter turn twist, hold for 15 seconds, repeat the process if applicable. And before I go to the videos and the step-by-steps on how to do that, I wanted to cover the data for the gluing cement and the primer as well. But this is the safety data sheet. So this kind of tells us a little bit about the glue itself. Did I highlight? Okay, yeah. So I wanted to zoom into the hazards. So it's flammable. It's bad for us to inhale. Again, that's why it's important for us to have our masks on. I wear gloves. We want to wear our goggles. Causes serious eye irritation, may cause respiratory irritation, cause drowsiness or dizziness, suspect of causing cancer, may form explosive peroxins. So those are the possibilities. Highly flammable, liquid and vapor. So I'm not showing everyone this to scare anybody, but as long as we're safe, I just always wanted to bring these up because that's something that I wanted to know when I first started using this. Because if any of you out there have used glue or PVC primers, you know, they smell, they're acetone, very, very strong smelling, right? So always make sure you have glasses on. You might think that none of it can flick up, but when you're gluing the pipe, something can flick up and get you in the eye or getting it on your skin. As long as you wash it, you know, as quickly as possible, it is still safe to use, but there is options of glueless fittings for PVC as well as the Blue Lock system. But just wanted to cover that just for everybody to kind of know. So staying connected. So we're going to talk about the gluing process. So again, make our cut, and I'm going to have a video that covers this, but I just wanted to show you step by step. We want to apply that purple primer. You can see here's the dauber. This is the cap. So this comes already equipped. You don't need to buy any additional things. We wipe the primer on the fitting and the pipe. Want to apply the glue. Same process, push it together. I always like to have a rag and kind of clean a little bit of the excess glue that drips out, because you do want to see a little bit of glue drip out. That's indicating that you did have enough. So I have a quick little 2-part video on cutting PVC pipe.
Hi, this is Brandon with the WaterWise Community Center, and in this video, we're going to break down the steps on how to repair PVC pipe. And just like with every job, we need to have the proper tools. So for repairing PVC pipe, we need an irrigation saw, PVC cutters, tape measure to measure the pipe that we're going to be replacing. And in particular, when dealing with PVC pipe, we need to use a PVC primer. I have 2 separate types of glues here. This one is blue glue and this is clear glue. Both do the same thing. The most important of all is your personal protective equipment. So you need a pair of safety goggles. And since we're using a solvent, you want to wear some sort of leather or rubber glove. In this video, we're going to be talking residential irrigation.
Okay. There we go, number 2.
So when cutting your PVC pipe, you want to make a nice smooth cut. So the first step in repairing PVC pipe is you need to apply primer to both the pipe and the fitting. So when applying the glue, we want to apply glue to the pipe, to the fitting, and again to the pipe. Then you want to put the fitting and the pipe together, doing a quarter turn, holding it for about 10 seconds.
Okay, I hope those videos were helpful. Again, I can't wait to see all of you again in person, where I set up a lab to where you get to glue some fittings together, do some repairs. Definitely my favorite part of doing these workshops is interacting and doing the hands-on activities with y'all. So there are some repair tricks, I guess, some components to repairing PVC pipe, especially repairing the pipes once they're installed. So there's something called a slip fix. So really, really handy tool, great for repairing after the valve. It does have O-rings to keep the water from leaking out, but not necessarily good for main line. So between the water meter service line and your irrigation valves, but I am perfect for doing repairs after the irrigation valve. So like this area here, so we had a broken T where we needed to cut out the T and replace it. But as you can see, when we cut that out, we have a big gap in our PVC line now. So a couple options we have. We have one option of getting a coupling, which is just a solid straight through socket. We would have to put one here, one back here. So multiple areas of gluing, and then glue in a new T. But Daniel's going to install this step-by-step picture of a slip fix. So when we have a broken fitting, we want to cut the pipe as close to the fitting as possible, but not so close that we have the glue still from the fitting. We want to cut back a little bit so we can have a nice clean pipe. And this is a slip fix. So this one in particular is a glueless option. This is PVC lock. So this works if you're familiar with shark bite in the plumbing industry. It has a double O-rings with little teeth. So as you push the fitting onto the PVC pipe, it locks and it seals. It's without glue. But the same process would work for a glued slip fix. So you can see this is telescoping fitting. So you want to extend it all the way out so you can measure the area that it's going to take up. So we cut the fitting. So this area is going to go here. And then we're going to make a cutting back here. So we make a mark. So always have a pin handy. So we're going to replace this entire section with this slip fix. After we cut, there's going to be some residual water in the piping. So you want to give it some time, let it all drain out, wipe it down, because we don't want to glue if there's water still coming out of the pipe. So we want to glue, primer and glue if we need to. This again is a glueless fitting, but if we were to glue, we want to do one side. We want to collapse the slip fix so it squeezes in like an accordion. So we have room. And then once we're glued, we want to pull the socket where the slip fix can expand, and we want to finish it on the pipe. So you can see it's fully extended. We covered that space. We wanted to glue the fitting on here and glue the fitting to the pipe. So this is a quick and easy way, because without using a slip fix, we would have to put a coupling. There would be a lot more bending of the pipe. We would have to cut a solid piece of PVC pipe to cover this area, and there's a lot of bending and moving. This is definitely an option where you can it's a less invasive for sure, because you can cut the pipes, put the slip fix in with it completely compressed, glue it, and then extend it to cover that space without having to bend the pipe and do some other wizardry on moving the pipe to get the glue on the fitting. So ongoing maintenance for our pipes, there's no ongoing maintenance for our irrigation pipes, right? It's just if an issue does arise, and it doesn't happen that often unless you have some invasive roots of a tree or heavy equipment driving across your yard, typically the fittings and the piping don't really have any issues. So there's no maintenance to do. And with that, I'm going to take a quick couple-minute break. So at this time, if there's any questions or comments, please put them in the Q&A or in the chat. And in 2 minutes, 2 to 3 minutes, I'll go ahead and answer any questions or any comments. So let's go ahead and take a quick little break. Okay, I'm back. Hope everyone had a chance to make some coffee or some tea if that's what they are into. Okay, so it doesn't seem like we have anything in the chat or Q&A. Not a big deal. If you have any questions, again, please feel free to do any questions. I know this is less interactive than we like, so if you have any specific questions or anything like that, please type it in. See if we can cover it. Okay, so now wanted to get, oh, okay, perfect. We have a question. Says, for the slip fix you showed, after the coupling is extended and attached, can the T be rotated to the right position, or does it need to be positioned first? Great question. So the answer to that is if you are gluing, the fitting, if it's a glued fitting, the one in the picture was a slip fix with a glueless slip fix, so the PVC lock version of that, which can be rotated after it is latched onto the pipe. So there's an added benefit. But in general, yes, you always want to glue your fittings to be in the position that that is desired, after the glue sets. So for that one in particular, it would have needed to be glued and then put to the side at a 90 degree so that it could be repaired and placed in the correct position. So that goes with any gluing that you want to do. If it's a T, if it's a 90 where you're needing to make a left turn or a right turn of the piping, always when you do the quarter turn, after you put the glue on and you're holding it, you have a couple seconds to kind of line it up, but always want to make sure that you're holding it as the glue is drying in the position that's desired. That's a great question. That's a great point. Again, I've made plenty of mistakes in my time, and I've done that where the fitting wasn't exactly the right way. And if it's a little bit off, certain repairs can be a little more forgiving, but in general, do your best as the glue is drying to make sure the fitting and the pipe, everything is in the right position, because once it is glued, it will not you will not be able to rotate it or move it. So great question. Thank you. So with that, I'm going to get into irrigation valves. Again, I would be passing around a lot of these valves where you would have your hands on them, but I did do a short video of dismantling a valve, and we're going to talk about the components. So irrigation valves. So here are some anti-siphon residential valves. So these are the standard valves for our homes here in California. We have to install these because they have a atmospheric vacuum breaker attached to the valve. So when installed properly, so 12 inches higher than any sprinkler head on the site. This needs to be higher than any of those sprinkler heads. That does not allow the water to be siphoned back into our system, because we don't want a contamination of our irrigation system getting pulled into the municipal water system or even our homes because of the pesticides and herbicides and things like that typically get put on your landscape. I'm not saying everybody does do that, but that's the idea behind having these irrigation valves for the residents, for a residential setting. So if you go to a park, let's say like our park here, our valves are installed underground, but that is because we have a backflow preventer. So the large piping, it's essentially a component of the irrigation system where it blocks all the water from coming back before it's attached. Well, it goes from the water meter to the backflow. So anyway, we have a protection there, whereas at a residential setting, you don't have a large backflow like that. So these valves are designed to isolate the valve that the irrigation zone that it's watering. It's protecting each one of those individually. So irrigation valves. So just some quick terms. Manifold is a grouping of valves. So going back to this picture, this would be considered the valve manifold. So grouping of valves. Irrigation valves are electric irrigation valves are powered through the solenoid with the two wires that are connected to the irrigation controller. They're normally closed, and the power required to charge the solenoid and open the valve is 24 volts AC. So our irrigation controllers send that 24 volts AC to the solenoid through the irrigation wires. There are some systems that are battery operated. So these are becoming more popular and higher quality, in my opinion, is they would require a DC latching solenoid. So if you are going to buy an irrigation controller that's battery powered, make sure that either they have the solenoid that you would need to replace in the package, or you make sure that you buy it, because a standard irrigation solenoid cannot operate on a DC battery powered irrigation controller. So some of the components, flow control. So this is the stem at the top of the valve, the bonnet, which is the whole upper portion of the irrigation valve here. So you can see where the screws are in. So the black part here, this is all considered the bonnet. Solenoid, which is again the electronic component of this irrigation valve, it has two wires that's connected to the irrigation controller. And then this is the anti-siphon, the atmospheric vacuum breaker portion of the anti-siphon valve. So again, just some more terminology. Again, solenoid. Inside the solenoid, there's a little plunger. So these valves, looking at them hydraulically and mechanically, they really operate on these small little ports. So there's a port here as water moves on this model here through the diaphragm. Water fills up in the bonnet in the upper part of the valve. There's another port leading to the solenoid. We have the plunger, which is closed, and then we have another port which goes to the sprinklers. So when there's no power to the solenoid, the plunger is down. It's keeping all this water on top of the valve is closed. When we send power from the controller to the solenoid, which is essentially a bunch of copper wiring, it energizes the copper wiring, causing the magnet to engage the plunger. Plunger lifts up, allows the pressure in the upper part of the valve to escape, and that allows the water from our water meter in our main line to force open the valve, and the valve operates. And then when the solenoid loses its power, the plunger drops again, pressure builds up in the top of the valve, and it closes. So in a nutshell, that's how these valves work. You know, that's a little bit harder to a concept to get off of just a webinar, but we'll have some videos coming up. So the diaphragm is the center part. So when I have the short video of pulling a valve apart, you'll be able to see that. So this is the moving component that moves up and down. When the valve opens, it's up, and then when the valve's closed, it's down. Again, those ports. So when I start going over the troubleshooting involved with the irrigation valves, I'll be talking about clogged ports. So this would be the solenoid port, and this would be the diaphragm port when we're talking about those. Flow control stem. Again, this controls how much travel the diaphragm goes. You can, as you screw the flow control down, that allows the diaphragm to move less, so that you can restrict the amount of water going through the irrigation valve. Again, the bonnet is the whole upper component of the irrigation valve. The valve seat, so this is the body, the bottom part of the valve. This is where the diaphragm sits on the actual constructed part of the irrigation valve. So issues with a valve not completely turning off or leaking a little bit, we want to look at that valve seat where it actually sits. You would be surprised at the things that can kind of get in through the water meter and go into these valves. Sand, rocks. On a larger scale, I was doing a consultation with a park and they were having an issue and there was a valve that was stuck during that time. We opened up the valve and it was a huge cap from one of the pipes. The city was doing a repair and one of their galvanized pipes that comes with a cap, and somehow that got in the line and that was jammed inside the valve. The valve was not closing and the valve was damaged. So things like that do happen, not very often, but checking the valve seat will cover that. So here's how the water moves. We kind of hinted on that. One thing, the irrigation valves, if you don't know which way the water's going, one indicator to know which way the water is flowing through the valve is the solenoid. 99% of the time, there's only one model I can think of that isn't the case. So you can go ahead and just assume that the solenoid is on the downstream side of the valve, or the side that's going to the sprinklers. The solenoid is going to be on that side. Right? So if you were like, I don't know which way to install this valve, you want to install the solenoid side of the valve, is going to be pointing towards the sprinklers and the sprinkler piping, where the other edge that doesn't have the solenoid is going to be connected to your main line or the water meter side of the valve that has constant pressure. The solenoid side does not have constant pressure. So that's the side to your irrigation valve or your irrigation sprinklers. So in lieu of having a hands-on component, I'd made a short little video of tearing apart a valve. So hopefully this helps.
The first part of the valve that we're going to talk about is the solenoid. Solenoid can easily be replaced by turning in a counterclockwise manner. As you can see there, that comes off. This is the electrical component. We want to check the port, make sure that's nice and clean. Second part is the bonnet. So the bonnet can be taken off with a screwdriver. As you can see, that is the upper component that comes apart. Now that the bonnet's off, we want to look at the diaphragm. So the diaphragm is the rubber component that sits between the bonnet and the body. It's the part that has the most mobility, tends to wear out over time. And we want to look at the valve seat. So this is where the diaphragm seals on the bottom of the body. I like to run my finger to make sure there's no nicks, that it's nice and smooth. And I also want to run my finger around the rim where the diaphragm meets with the body. So now we can reassemble our valve, putting the diaphragm in place, assembling the bonnet. One very important thing when putting a bonnet back on, we want to tighten in what's called an X pattern, going on one side of the bonnet to the other to make sure there's even pressure around the bonnet. Once everything's nice and neat and tight, we're ready to turn the irrigation back on.
Okay, hope that gave you a little bit of clarity. Surprised how fast I did that repair. Okay, so now I'm going to do another series of Is There a Problem? So these are pictures that I've taken in the field. Is there a problem? Yeah, I think there's a little bit of a problem here, right? So what is it exactly? What do you guys think is the issue here? We have leaking water. Where's the water coming from? So if you look closely, you can see underneath the solenoid here, right at the seam where the bonnet and the body, where the diaphragm is, right there in that center line, that's where the water is coming from. And this does happen over time. So this is an area where it just wore out. So when the valve's operating, so when the valve is powered, so this was when we were doing a check. When the system is running, so when this valve is running for its allotted time, it's leaking profusely like this, right? Once the valve is not operating, where it's in a resting state, it does not leak. So that could be a little bit of an issue if you don't do an irrigation check. You might not see this leak. Over time, you can see that this is a really wet area. This was pretty sandy, so the water wouldn't puddle as much. But something that does happen. So there's a couple options for repairing this. You can buy a diaphragm, but however, the diaphragms do cost quite a bit of money, and certain valves it's best just to replace, unfortunately, than repair. But it is an option of finding those diaphragms. A diaphragm replacement on this valve would fix the issue. So it's just a little bit of a zoomed up picture here. You can see water's coming out right there at the diaphragm, right at the seal. All right, so here's a picture where irrigation valve was eliminated. That's completely fine. But you can see the repair here. The irrigation valve was much higher, so now this is not installed up to code. The repair was done and the valve was lowered. So this is not the prescribed clearance for this anti-siphon component to be operating properly. So this is not up to code now. So something to think about when you do need to do a repair. You got to keep the height. Sometimes you have to, when it comes to replacing a valve, you have to dig out the entire manifold, redo the piping down below so that you can have the proper elevation. Sometimes that's just what's needed. And typically we want to repair like for like, is what we call in the industry. So these were the original, these are brass valves, anti-siphon, but this is called an adapter, brass adapter. They replaced the brass valves with a plastic valve. You can see it's a lot smaller of a valve, so the flow going to the system is a lot less, I should say. Ideally, you would want to replace it with the same type. What would you think would be one of the limiting factors for replacing this valve? Probably price, right? Where this valve with the adapter and the body, probably, man, it's been a while, but it would probably, if I had to guess, around $60 to $80, where this valve is closer to $20. Which one will last longer? The brass will, of course, right? So certain things to think about, but now a different valve, smaller valve, this one will give less water to the zone. So if the zone needed more water, let's say there was more sprinklers on the line because they had a larger valve, now the system won't be operating as efficiently. So things to think about. You always want to replace what was there. So this valve went out. Instead of replacing it with something different, if possible, go with the same one that you're replacing it with. So now we're going to get a little bit into the nitty-gritty of the repairs for irrigation valve. So when we're thinking about an irrigation valve, we want to do the process of elimination. Kind of gives us an idea, where should I start looking at if my valve is not working, right? It's either hydraulic, so something has impaired the flow of the water. So something is stopping the water from flowing, that would be hydraulic. Mechanical, so something is physically stopping the valve from functioning, so the valve cannot open and close on its own, something mechanically. Or lastly, electrical. So something is wrong with the electrical component. So that could be the wiring, that could be the solenoid, that could even be the irrigation controller. So the three possibilities for a valve not working: hydraulic, mechanical, electrical. I've seen almost all of the possibilities. For hydraulic, I once replaced a valve because it wasn't operating when I first started doing irrigation, and I replaced the valve, put a new valve in, turned it on, no water still. Come to find out, somebody turned off the water at the meter, right? So the valve wasn't faulty. It was that the hydraulics, the water was impaired. The water flow was impaired. So going through this checklist kind of gives you an idea of where to start looking. But you learn. So if your irrigation valve is stuck open, so when we say stuck open, that means that it's running nonstop. So again, our valves, without being powered, they're stuck in a resting state. Their resting state is closed. So if the valve is stuck open, that means that something's wrong. So what possible culprits can we look for? So incorrect controller settings. That does happen. I don't see that happening a lot, but the irrigation controller sometimes, I've seen it where someone had thought that they were putting it for 10 minutes, but they put it for 10 hours. Sometimes the irrigation controller can just malfunction and constantly send power to that valve. It doesn't happen that often. When we go over the multimeter, we'll go over how to check that, but that could be a possible culprit. A worn or damaged diaphragm. So going back to that video, when you remove the bonnet, that's that rubber component that moves up and down. So that's this section here. Worn or damaged. So over time, that's moving up and down, especially if you live in an area that has hard water. The diaphragm will wear and could break. If there is a tear in that diaphragm, it won't keep the water. There won't be any closure of the valve, so that would make the valve stay open. Debris in the valve, so that's anything that kind of got in there that shouldn't be. That could be silt, sand, rocks, any kind of debris. That could be an issue. Loose solenoid or bleed screw. So if you unloosen the solenoid to activate the valve, if you don't close it down completely, or the bleed screw on the side, that could keep the valve stuck open. So it might not be an issue with the valve internally. It could just be that those bleed screws or solenoid is not completely turned tight so that the seal can happen. Seen that before plenty of times. Damaged valve seat. So again, where that diaphragm sits on the body, it's supposed to completely seal, watertight seal. That could be damaged from, again, contaminants getting in there, cutting it, or things like that. Insufficient force on the top of the diaphragm. So this one is also less common, but the ports could be a little bit clogged and not allowing enough pressure to build up on top of the diaphragm to close it when the valve's at rest. So that's if a valve is stuck open. So now what about if it's weeping? So weeping valve is just a slowly but consistently escaping water from the lowest sprinkler head, typically on the line, because again, water is always going to go to the least, from high potential to low potential. So the culprit, if our valve is leaking just mildly, a damaged solenoid seat. So if you do open and close your solenoid to manually turn your valves on a lot, there could be some damage in there. Not getting a complete seal, that would cause a little bit of water to be trickling. Again, weeping is just a little bit water trickling. Damaged valve seat, so it's not sealing down here at the bottom, or any kind of small debris in the valve that would be causing that weeping. So if you want to get in there and try to repair this valve, if you do have a weeping one, opening up the valve, flushing out the valve, getting a bucket of cold water, dunking the diaphragm in there, trying to clean out is worthwhile if you want to go ahead and do that. Another indicator of a weeping valve, if you have one of your sprinklers, this is always the indicator for me, is if you're walking your site and you notice one sprinkler is like constantly wet, and there's a real good indicator is like green moss growing around the top of the sprinkler head. If you've ever seen that, that's indicating that a valve is weeping. So not completely water running down the street, but it's just that constant dripping and water coming through. That would be a weeping valve. Now let's look at the opposite. So what about if the valve won't open? What are the possible culprits? So we had what happens at the valve. What are the possible culprits if the valve is constantly running? So now let's look at what if the valve just won't open? The flow control stem could be down. Seen that before, right? Sometimes people just want the valve to shut off. You can just turn that flow stem all the way down, and it won't allow the diaphragm to open up. The solenoid could be bad. This happens as well. We can test with a voltmeter to see if there's an issue with that, and we'll go over that. Or we can have plugged ports. So again, we talked a little bit about those ports. So we have the port going through the diaphragm to the upper chamber of the bonnet, and then we have the other ports right here on the solenoid. If those do get clogged, and those can get clogged from hard water, those can get clogged by small little debris getting stuck there over time. If those are plugged, then the valve is not able to allow the pressure from the top of the diaphragm to drop and allow it to open. So those ports definitely can get clogged. I want to say fairly easily, but that is an issue that you can run into. It could be that the solenoid is not receiving any power. Again, so the solenoid needs to receive power to magnetize, pulling the plunger up to allow the pressure off the top part of the valve. And might be the case that it's not getting any power to do that. That's why it's not turning on. What would cause that? Broken field wire. So that's talking about the wiring that's connected from the irrigation controller, typically underground for quite a long time, and then going to the irrigation controller. So somewhere between the controller and the solenoid, there would be broken wiring. Bad connection. So connection between the two wires coming from the solenoid. We connect those with wire nuts to the what we call the field wires, the wires that connect to the controller. Those connections do go bad. In residential settings, I see that quite a bit where the connections are not waterproof. So you want to use the proper wire nuts for those wire connections. So we'll have some pictures of those being installed improperly. So a couple little tricks. So if the valve won't open, we went over what the possible culprits are, but how do we know if the valve's not opening, what can we do? So if we want to get our hands on the valve, we want to close the bleed screw or open the bleed screw, right? So we have bleed screw for external. So this one is on the top of the flow stem. Some of them are on top of the bonnet. These are the little screws that we turn and then water will spill out. That's allowing the pressure to leave the top part of the bonnet, allowing that drop in pressure to open the valve. You can also turn the solenoid breaking that seal underneath, allowing the pressure to go, the pressure to drop and the valve to open. So let's say we turned on these manual bleeds, either the screw or the solenoid, and the valve still did not open. There's no water to the valve or the bleed port. We want to check for flow control down and then look for the diaphragm. The diaphragm also, if you don't use your valves for long periods of time, they can, or if they don't have water, let's say that you turned the water off to your irrigation system and it's sat for a very long time, the diaphragms can dry out and become stiff and won't move. Before I go to that, so another thing to check. So if your valve isn't coming on and you turn your bleed screws and the valve doesn't come on, if you use your external bleed screw, if water's coming out and it's continuously coming out, but the valve still is not opening, then you have an issue mechanically with the valve. Something's going on internally in the valve, because if water's coming out of our bleed screw, that means that we have water available to the valve, but the valve won't open, right? Because we're bypassing the electrical. If I turn the bleed screw and the valve turns on, then I know that it's an electrical issue why the valve's not turning on, because the bleed screw turns on, I have water available, and the mechanical components are operating and the valve is on. So that's one way to check. And then if I turn my bleed screw and water comes out, so let's say for a couple seconds, then it slowly stops dripping and water stops coming out completely, and the sprinklers didn't come on, then I know that there's something with the hydraulically with the water coming in. Either it's clogged or a valve is off, something's off to where I don't have enough water for my irrigation valve. I don't know that I have a slide for that in this, but so just to review, by turning our bleed screw, if I turn my bleed screw and water's coming out constantly, but my valve is not opening and the sprinklers aren't coming on, I have an issue, a mechanical issue with my valve. Something's going on inside. That could be the ports again, the diaphragm, something like that. If I go to my bleed screw and I turn it on and water's coming out and my sprinklers turn on, then I know the issue is electrical. So there's something electrically wrong. Power's not going to my valve to turn it on with the controller. So I close it up. So, and then the last one would be if I open up my bleed screw and water spits out, but only for a couple seconds and then stops. I know that the reason why my valve's not coming on is there's something hydraulically. There's not enough water coming into the valve for it to operate. So just by doing that external bleed screw, you can figure out, hey, why is my valve not coming on? So hopefully that gave a little bit of ideas. So now we're going to look at solenoid diagnostics. So we're going to cover using the multimeter really quickly. Unfortunately, we can't do that with a hands-on component, but we're looking at our ohm readings. So anything from 0 to 6 means there's a short in our solenoid. We want to replace it. If it's from 6 to 15 ohms, slow burn draws excessive amps. So maybe the valve turns on sometimes and doesn't, or sometimes it does not. If our reading is anywhere from 15 to 50, and I would extend that to 100 ohms usually I've seen is a good solenoid, meaning that it's operating properly. And then anything over 100 ohms, There's usually a break in the internal wire. You want to replace a solenoid, or if you see an infinity sign, or some meters will have an OL, or it'll beep at you. That means that there's a break in the wire, or a bad connection with the solenoid. That means we need to replace the solenoid or the wiring. So what am I even talking about? So this is the multimeter that we talked about. A ton of those are available anywhere between the range of $15 to a couple $100, depending on what you want from them. I think this one was from big box store. I think I paid like $40 for this one, 40, 50 bucks. Anyone that you can find, all you need to have is resistance reading, which is the omega sign here. And we need to test voltage. So volts, AC volts, AC voltage. So as long as your multimeter is able to do that, we're good to go and do. Since we're doing very minimal checks where these tools are designed to do electrical work. I've used it on repairing a TV. I've used it on working on vehicles, working around the house. So they are very versatile, but for what we're talking about, all we need is a resistance or an ohm reading and then voltage. So checking a solenoid. So these are the two leads that come out of our solenoid. You want to take the two wires, put around one on each lead. Here, the resistance reading is at the bottom. Here's the omega sign. I turned it to 200. And I want to observe what the reading comes up. So this gives me a reading of 43.6. So that's ohms. So that falls within our reading of 15 to 100 ohms. So this is a good solenoid. Right, so this was another property. So I checked this reading because this valve was not coming on. So we have the common wire here. So a common wire, you want to connect all the valves. One of the leads, they all go together. Typically, it's the white wire connected to the irrigation controller. So the bundle of wires here have one white wire, which is the common, which is the return. So we want to connect one of our wires, one of the two coming from the solenoid. One is designated. It doesn't matter which one, but designate one to the common wire, and then the other one is connected to a station wire. So here I have my two wires connected, and I'm getting a reading of 2.3. So that would indicate a short in the solenoid, meaning that the wiring is crossed. So it's not operating properly. The controller is not going to run this valve. So you don't have to necessarily take them apart, like in this picture. This is my fancy little showpiece, where this is what we see in real life. So this is my station wire, plug one in there, and I plug the other one in, connected. So you want to jam it in there. You need to touch the copper component of the wire, not the coating. So you have to really jam it in there. And that's my reading. So this was an electrical issue. Ongoing maintenance for valves. There are no ongoing maintenance for irrigation valves. We just want to keep an eye on them when they're running. We want to see if they are leaking. We want to follow this protocol. Again, I know that was a lot of troubleshooting and PowerPoint slides to cover, but a PDF is available online of this presentation. So I'm going to go ahead and jump into overhead irrigation. So what is overhead spray? So overhead is irrigation device that puts water into the air. So this is pop-ups, rotors. We can see rotating nozzles. That's what we're talking about when we're talking about overhead sprays. So just to have some parts breakdown. So this is a pop-up here on the left. We have the inlet. So this is where the PVC pipe and then the adapters that connect. There's an inlet on the bottom. We have the body, which is the bottom. We have the cap, which is the part on the top. We have the wiper seal, which is typically the white part that's surrounding what we call the riser. So this is the component where it's usually at rest, is inside the body. And then when the water pressure comes, it pushes up, the riser pushes up. So we can get leaks around the wiper seal because it is constantly getting rubbed as it goes up and down. The cap can leak because there's just a small little O-ring and it's just a threaded component there. So that can leak as well. On top of the riser, we have the nozzle. And then radius adjustment screws on the top, on some that we can adjust the radius of the nozzle. Here's a little more, you can see a little bit more detail of a rotor. So this is a gear rotor. They have the same components. The nozzle is a smaller piece inside of the riser. So the riser is the whole part that rotates. Does have a wiper seal, a cap, body, inlet. So here's a typical example. So this is just the standard pop-ups, standard sprays. Here's a rotor. This is watering a slope. You can see it's at an angle to ideally match the slope. So this is like another option if you do have the room. It is a riser, which is just a solid riser, similar to what we have here. And this is what's called a shrub adapter, where it adapts from the 1/2-inch thread of the riser to a nozzle thread, and then a nozzle, and then the nozzle goes on top of that. So now we want to talk about choosing the right nozzle. What nozzle do I use? Something that I had to learn. And once I learned these couple little things, it all kind of made sense. So all of these nozzles are numbered. So the number associated with this nozzle tells me how many feet from the nozzle the water is designed to spray. So 5 foot means that shoots 5 feet on this side, 5 feet on that side. 5 feet if it's a half. If it's a 360, if it's a full, it's gonna give me 5 foot circle, 5 feet from the nozzle itself. And we can guess what it's gonna be with an 8, 10, 12. We have typical radiuses. We have 90, 180, 360. You can get specialty ones with these in-between radiuses, which do come in handy. However, there's a lot of adjustable nozzles where you can fine-tune these different arcs, which is also handy. So just going back really quick to choosing the right nozzle. So how do you know which nozzle to put in? So what you want to do is, if you have a system and you're doing maintenance, you want to turn on your irrigation system and then simply measure how far one sprinkler is to the next sprinkler. By doing that, that'll give you how many feet you need that sprinkler to, that nozzle to put the water. So if I measure my sprinklers out, I'm like, okay, they're every 10 feet, it's a 10-foot spacing. I need to replace this nozzle with a 10-foot sprinkler, or sorry, 10-foot nozzle. Different types of sprinklers. For more water efficient, we have rotating nozzles. These pictured here are MP rotators, which is a Hunter product. There's also Rainbird, who makes their own MP, their own rotating type nozzles. Toro makes their own, almost every manufacturer, K-Rain. So if you're looking for rotating nozzles, and the benefit of the rotating nozzles, so they are adaptable to a standard pop-up spray. So they thread in just like a normal nozzle, but they apply water in these streams. So it's closer, it more closely represents a rotor than a standard pop-up spray where it's just a fan and is prone to misting, where these rotating nozzles apply water slower and slower and larger droplets. So the soil is actually able to absorb it better. And there's also precision nozzles. This is Toro's answer to the standard fixed sprayed nozzle. So the fan nozzles, they're supposed to, they break up the water a little bit to slow the spread of the water as well. So fixed sprays, so this is a fixed spray. So this is a 180-degree nozzle. And then there's also variable arc nozzles. Again, those can be adjusted from 90 degrees up to about 210. So using your channel locks or specialty tool, you can either close or open it to water more or less, depending on your site conditions. So for gear rotors, these cover larger areas. So we see these a lot in turf areas. Larger turf areas, I should say. They rotate, so they apply water in a stream, so they have to run longer because they aren't constantly fixed and spraying. And again, rotating nozzles apply water slower with larger droplets compared to the standard fixed sprays. They can be retrofitted onto a standard pop-up sprinkler. And they are rebatable in our area, at least, up to $5 per nozzle. They are definitely more expensive than a standard nozzle, but with the rebate, they do come in handy. And for turf areas, you'll see a lot of benefits if your system's set up properly and these are installed. Definitely less waste of water. So real quick, short little video of the adjustments on a rotating nozzle so you can kind of see. We have these all over our demonstration garden where we would go see them run in person and you could adjust them. We're going to watch a video.
The nozzle itself has a fixed arc on the left side, and on the right side, it is adjusted by moving the little silver ring on the very top. If you turn the ring counterclockwise, it will close the spray and reduce the arc. By turning it to the clockwise, it will actually open up the spray, giving you a wider arc. The left side is fixed, so in order to change that, you will have to grab the neck of the pop-up while it's running and gently give it a twist to the left or to the right. That will change your starting point on the left side. And again, with the silver ring, you can open or close the right side.
Okay, so you can see that easy. So a lot of these newer adjustable nozzles really do come in handy when we have areas that are not a strict 90-degree or a 180-degree. So how do we replace a sprinkler? So I have another couple short little videos on replacing a sprinkler. And bonus points if in the chat if anyone can tell me what size shovel that is.
Hi, this is Brandon with the WaterWise Community Center. This is going to be part one of a two-part series on how to replace a sprinkler. So the first step is identifying the sprinkler that we want to replace. And for now, the only tool we need is a shovel. So let's start digging. So now that our hole's dug, Our sprinkler is easily accessible. You might need a pair of channel locks. In this case, since I dug such a nice hole, you can just spin the sprinkler off, and we're ready to put in our new sprinkler. Now that we made sure we had the right sprinkler that we need to replace our broken sprinkler with, we just simply screw in the sprinkler and start putting the dirt back. And that's it for part one. Hi again, it's Brandon with the WaterWise Community Center, and this is part two in our series on how to replace your sprinkler. One of the important things while setting our sprinkler back is to make sure we compact the soil around it. Make sure that the sprinkler is up straight. The sprinkler that we installed has a flush cap. Flush caps are great. They allow us to run the system, get out any debris, anything that might have got into our line when we're making the repair. Last step, removing the flush cap. And I just took the nozzle out of our broken sprinkler because the nozzle is still good. Simply screw the nozzle in. And so that's it. Thank you for watching this two-part series on how to replace a sprinkler.
Okay. Hope that helped a little bit. In the chat, a 5 or a 6-inch shovel. Yeah, it was a 6-inch shovel. Good job. Kind of cheated a little bit with a bigger shovel. I see that somebody raised their hand. We don't aren't set up really to answer or let other people talk, but if you want to put it in the chat, if you had a comment or anything, I will absolutely get to whatever it is that you would like to mention. So ongoing maintenance. There is a little bit of ongoing maintenance with sprinklers, things that'll help make our system operate more efficiently. One thing is a fixed spray. Again, the standard spray, they're highly affected by water pressure. So this irrigation system had a pressure regulator for 50 PSI. Irrigation or pop-ups with fixed sprays are designed to operate at 30 PSI, like to be this most efficient way of watering without misting, without overspray. So anything higher than that, which happens quite often, will cause these standard fixed sprays to waste water. So that's why a lot of professionals and water agencies say adjusting to a rotating type nozzle, they actually operate better at a higher PSI, closer to 50 PSI, and they can accommodate that higher pressure and they won't waste and mist as much. So going back to that, so state of California passed a law that irrigation sprinklers, so any sprinkler sold starting, I think this year, 2021, they are all pressure regulated sprinklers. So the body is pressure regulated. So when the water from the system passes through that sprinkler, they are regulated to 30 PSI. There's 30 PSI and 45 PSI regulated sprinkler bodies, and those will help keep the pressure at the nozzle in the appropriate amount. So we'll see how that works over time as far as irrigation efficiency, but something to keep in the back of our minds. Pressure regulation. So is there a problem here with this irrigation valve? There are a couple. So the top part of this rotor is damaged. That happens. This is in a park area, but any high traffic area, people step on it when they take the weed eater to kind of clean this area out. They could damage it. Seems to be working all right, but the issue here is that the grass has grown much higher than the soil level over time. So now all this runoff here is a deflection of the grass surrounding that sprinkler. Here's another issue. This is just a rotor that needs to be replaced. Around the nozzle and the top part of the riser is leaking. You can see all these weeds popping up heavily around this sprinkler. Again, that's one of the indicators that this area is really wet. Here's a broken cap. You can see the force of this. Again, this is a commercial, this is at a park. But you can see the force of that water coming out. This is behind an acacia shrub. So you can probably guess that this doesn't get a lot of attention, at least visually, unless you turn the system on. And then here's a good representation of high pressure. So this pressure was closer, I would say, to 100 PSI when we did this evaluation. But since these are just a regular fixed spray standard nozzle, you can see all this misting, basically creating a fog because of the high pressure, the high velocity of the water moving through the nozzle. So that's how a lot of this water just evaporates or kind of gets blown away with the wind and doesn't land on the intended site. In this case, it would be this planter. There's a good representation of that misting. So why all of this matters? So irrigation system performance, in a term we use in the industry of distribution uniformity, which just simply means how evenly the water is being distributed over the zone. All right, so this is the ideal situation. This is nice and uniform. This is the soil, representation of the soil level. And then below the soil, this is the saturation level, fairly even. Again, our irrigation systems are not going to be 100% efficient, but we want to get it as close as possible. So this model is not uniform. You can see these large differences in wetted area below the surface. This is because it's the water being applied is not evenly distributed. So low distribution uniformity, high distribution uniformity is the goal. So how do we even know? We don't go here and cut out a square of the soil and dig it all out and see what's saturated. That's not reasonable. Well, there's some tests you could do. Part of our service of doing our landscape evaluations, we go out, we'll run the system for a certain amount of time, depending on the sprinkler type. And we have these, what we call catch cans. We use fancy ones. You can use solo cups. You have left over from a party, or you can use, I've used mason jars, anything that kind of captures water. You need to be able to calculate the surface area of the opening to put into the calculation. But this is a way for us to calculate how evenly the water is being distributed. So if you're ever out and about and you see water running during the middle of the day, and then you can see all these little cups out there, you can see that somebody's doing an irrigation audit. We get looks all the time. People are like, what's going on? What are you guys doing? Seems very strange. So we can do it on pop-ups. We can do it on rotors. Rotors are just more spaced out because it's larger areas. So now that we know how we can kind of check for distribution uniformity, and when we get back to teaching professional classes, I teach irrigation audit classes. So if you are interested in the actual math that goes behind it and how we calculate that, it's quite in depth, and we won't be able to cover that today. But if you are interested, please feel free to email me or just look on our Eventbrite for the professional classes coming up. So what will cause our irrigation system to not have high distribution uniformity? Tilted sprinkler heads are a big one. Just over time, our sprinklers will become tilted in the soil because the soil expands, contracts, people walk on them. Things just happen. Plant interference, the plants in turf grass, it grows taller, or if there's shrubbery around, if anything that's going to grow larger and interfere with the spray. We have mixed nozzles and other equipment. So different types of nozzles throwing different amounts of water. Sprinkler spacing. So if it's designed to be 10 feet, 10-foot spacing, if sprinklers are not uniform in their spacing, things like that can lead to that. So very quickly, we're going to talk about spacing. So we want to have equal spacing, what's called head-to-head coverage. So this is a really dated example, but it really is what we need here. So when you design an irrigation system, you want one sprinkler head to spray and meet the other sprinkler head, because sprinkler heads are not designed to water within the first, like, let's say 6 to 12 inches. It relies on its sprinkler adjacent to it to spray that with the end of their nozzle footage. So for this, if this was 12 feet, we would need a 12-foot nozzle here and a 12-foot nozzle here. That ensures that this whole area is evenly distributed. So if we were to draw this out, every dot here is a sprinkler, where this is a 180, this is its spray pattern. So it's designed to hit this sprinkler, this sprinkler, this sprinkler. This one is a 90-degree, it's designed to hit this sprinkler and this sprinkler. So once you draw it all out, it becomes a work of art, like a psychedelic painting for your office, but it's irrigation mapping. So you can see you want everything to be perfectly overlapped. Each sprinkler is hitting its adjacent sprinkler. Okay, so we got a question. Question is, do the plant roots not spread the water to the spaces that perhaps don't get enough water, or is it like in more extreme cases? They can. So the question is, if where the distribution uniformity is low, do the plant's roots kind of travel the water around? The answer is yes, essentially they do. But the problem with that is the surface. When we don't have enough water, roots are going to go to where the water is. So the roots in areas where it's a lot drier and the water is not getting there, the roots are going to go higher. And if they go higher, they're going to dry out sooner. So the issue of uneven distribution, we're going to have, especially in grass areas, you're going to see they'll start to see dry spots, right? Yellow spots popping up. That's a really quick indicator, especially when it starts warming up. You can say, wow, I think my uniformity is a little bit off. And typically, the way to fix that is we just overwater, right? We say, okay, well, we're just going to bump up the time. And so now those areas that barely get enough water get enough water. But now we have a lot more of the water going past the root zone. And so we're overwatering the majority of the area to compensate for that. So when it comes to really dense plantings, uniformity is a lot more prevalent, and we need it to be uniform for plant health, just in general. But relying on the dry spots for the surrounding water to kind of accommodate those dry spots, that's typically not the best option. Although if we do have a different plant palette that can deal with that, with deeper roots and wider roots, that is something that will be okay. Hopefully that answered the question. Okay, another question. What is the best tool for trimming overgrown grasses around sprinkler heads that is blocking the flow? Great question. There's quite a few options. I mean, you can use a shovel. You can use a string trimmer if you have one, a weed eater. But the best thing to do is just to cut it out. You want to cut the roots out. There's even tools that have just like they're a circle and it has a big handle, kind of like a pogo stick, and you just stick that down and turn it, and it kind of cuts all the roots and cuts a circle around your sprinkler heads. In some cases, the grass is just over time, the roots have grown and there's thatch and it's just so much higher. You need to just get in there and cut your grass at an angle. You just want to make sure that when your sprinkler is fully popped up, that it's able to throw over the sprinkler, or sorry, over the grass without being disturbed. So if in some cases, it might just be a better option to replace the sprinkler with a taller one. So if it's a 4-inch pop-up sprinkler, replace it with a 6-inch, so it'll pop up an extra 2 inches or so to get over the grass. I know that it really depends on the situation, and a lot of the irrigation, especially at our homes, have been installed quite some time ago, and we've had repairs here and there. I guess it kind of just depends, but I mean, just using a shovel or something to kind of cut back the roots and give a little bit of space helps a lot of the time. Great questions. Right, and so here's another example of the distribution uniformity. So if we don't have the proper head-to-head coverage, again, head-to-head coverage meaning this sprinkler sprays and hits the head on this side of the sprinkler. So head-to-head coverage. If we don't have that, we have areas of too much water because we have the majority of the flow of the water coming from both nozzles in the center, and we have a lot of dry areas surrounding the sprinklers. So we want correct and good coverage. So typically we have a little exercise of doing a quick little design, but just in general, if you're thinking about sprinkler spacing and design, you want to start with the corners, add heads as needed for head-to-head coverage, use the sprinklers with the longest radius to minimize the number of heads, size the sprinkler limited by the width of the area and the system hydraulics. So, yeah. So starting with the corners first, we're just going to do a square just to save time and give you an idea. So we want to measure the distance and see what nozzle type we need. So in this case, it's a 20-foot spacing. So we want to have, typically that length, we would use a rotor because they cover a larger area. So when using sprinkler nozzles, we want to have what's called match precipitation rates. So that means that every sprinkler is delivering water at the same rate. We measure that in inches per hour. So we want to make sure that if I have a 180, or if I have a 360, or if I have a 90-degree arc, that all the water is being delivered at the same rate or the same speed. This really comes into play when we're dealing with rotors. So we want to have match precipitation. So sprinkler layout again. So working with the corners, we move inward, add heads as needed, maintain head-to-head coverage and equal spacing. Which might be difficult for odd shapes because again, in our landscapes, we don't necessarily. I mean, I personally don't like just everything being little squared areas. I like to have soft edges. I like to have a little bit of room to go. So designing a sprinkler system like so, we would just start at corners, get our spacing, and then in the middle, make the grid as even as possible. So one of the things I talked about was tilted sprinklers. So this happens quite a bit. Again, so this is here at our park. I was doing a irrigation evaluation here at our park, which I do once a year. And I noticed that some of the rotors, just from wear and tear, started tilting, which makes our distribution uniformity go down quite a bit because it's not applying water evenly. It's spraying shorter because it's tilted to the left, and then spraying up and misting. So there was a couple issues. So to fix a tilted sprinkler, you just dig out the sprinkler. So you can see this is a rotor. So ideally, this should be at least 2 fingers to 3 fingers away from this curb, but that's how it was installed. So let's do your best to keep it straight. Move it back and forth. Make sure that the spray is going to stay on the turf and not getting into this mulch area. And once you get it kind of set up, you want to slowly start putting in the soil. So again, I'm using the smallest 3-inch trenching shovel for these little detailed works. You go and start compacting little by little, because you want to make sure that when you leave the sprinkler, it's nice and settled. Another way you could do this repair, which I've done in the past, is you can get construction sand. And at the bottom to about halfway up on this sprinkler repair, you would put the sand, because you can really compact it, and it'll make sure that the sprinkler, I should say, it won't tilt again. Not always necessary. I didn't do it here. Again, once you get it nice and straight, you want to make sure you run it. Again, I put my cans out there because I want to make sure and calculate that it's distributing evenly. So that's how we kind of fix tilted heads, and that works the same for pop-up spray. So I'm going to do a little bit of sprinkler rehab, short little video.
So the first step is knowing that you have an issue in your landscape. It's finding a dry spot. The next step is to turn on your irrigation system. Here we have a clogged nozzle that seems tilted, as well as a sprinkler that's turned, so the arc is hitting more concrete than it is landscape. So to adjust the sprinkler, we want to turn the system on and then get our pliers out. Once we have our pliers, we want to gently grab the stem, gently turning to make sure that all the water is hitting the landscape and not any of the concrete. To replace the nozzle, you want to pull up the stem, unscrew the nozzle. Oh, we can see this one's clogged here with, seems to be quite a bit of debris. So let's go ahead and replace this nozzle. We want to put a filter in. And screw in the new nozzle. Another thing we want to make sure is that this one is going to hit only landscaped area.
So there you go. Flushing a nozzle, adjusting it. Again, those tongue and groove or channel locks, pliers come in really handy. Just grab it really quick. Now I am going to go over drip irrigation. Is there any questions? Doesn't look like it. Any questions, comments on nozzling, sprinkler bodies, valves? No? Okay. Put them in the chat and we can cover them as they come. So going back to this original picture of the valve manifolds, what kind of changes a irrigation system and how to convert it to a drip irrigation system? It starts with the valves. You can notice that 2 out of the 5 here have something coming off of them. This is a filter, and below it is a pressure regulated system. So this is absolutely necessary for drip irrigation because the pressure needs to be lower and constant. So we drop it down to 30 PSI for the entire zone. That's because our drip tubing is glueless. They're just a insert fitting, so we don't want things to blow apart. And also the benefit of our drip irrigation system is, in fact, it's dripping of the water. So a very low, slow volume of water that we run for a longer period of time to give adequate watering, but it's that very small ports, which we call emitters, that allow the water to drip very slowly, which can get clogged very easily, as you could imagine. So we have a filtration filtering system. All right, so here's an anti-siphon valve like we have a residential settings. Here's the filter and the pressure regulator. This is a inline valve, so like a commercial setting that has a backflow preventer. And we have the regulator and the filter. So here again is another pressure regulation system, just to give you some more ideas. So here's a hose bib. So this is was a garden installation in the backyard. So they tapped into an existing hose bib. So they have 4 separate valves for irrigation, for drip irrigation. You can see that by the filter and the pressure regulator. So pressure regulation. So drip irrigation needs to be pressure regulated at 30 PSI. And then you always want to check manufacturer's specifications on inlet pressure. So what does that mean? So when we have the pressure from our water meter, it varies depending on your location. I know over our service area, just by doing evaluations and knowing the area quite well, we have anywhere from on the low end of 60 or 70 PSI from the water meter all the way up to over 100, close to 110, 120 PSI from the water meter going into the home and going into the irrigation system. So you can probably imagine some issues could arise. So especially with these regulators for the irrigation valves for the drip conversion. This is the brand Rainbird. There's also Hunter or Toro. They make more commercial, more expensive, of course, but higher quality drip parts. So this one has an inlet pressure of 150 PSI. So this can take 150 PSI maximum going in, and what comes out is 30 PSI, which is what we need for drip. And the reason why I bring this up is, I guess it's not recently because we haven't done it in over a year, but within the last couple of years, I've gone to a couple homes through our program, and they've had issues where this cap here was leaking and cracked, and every time the water came on, it was just pouring out of this and breaking because the manufacturer of their pressure regulator had a maximum inlet pressure of 75 PSI, and they had over 100 PSI. So the pressure regulator was not able to hold back enough of that pressure, and it was damaging it. So always check your pressure before you buy pressure regulators or even any component. It's always good to know what your pressure is at your house. So what does that even look like? So this unscrews here, and this model pulls out. This is your filter. So you want to clean this at minimum twice a year, just by making sure your irrigation system is off, unscrewing it, just taking a bucket of water, something where you can dunk this in with your hands. I wouldn't use anything that's too abrasive, just kind of slightly rub it, kind of get any debris of it off of the filter and then put it back and you should be good to go. Here it is completely pulled out. So really quick, so these are the components for the drip irrigation system. So you can see we do have the T fittings, we have the 90 fittings, we have the couplings, but you notice that they're not glued, they're insert fittings. So they have barbed components of it that goes inside the drip tubing and will not come apart. Again, that's why it's essential to have that lower 30 PSI rating. So repairs. So here's a home with drought tolerant with DG and a more succulent desert scaping with drip tubing. Is there an issue here? There's actually not an issue. This is what you want to see where the water is being emitted on drip. You'll see it puddle up. You want to make sure that the areas where it's puddling up is where the plants are. But even though it is at a lower pressure, this is a broken coupling. So this is a drip tubing completely broken. So it's a 17 millimeter, smaller than our hose at our house, but it does emit quite a bit of water still if it is broken. And when thinking about maintenance for irrigation, drip irrigation, always try to keep extra parts on hand. Although it is cheaper parts in the short term, drip irrigation, it does tend to break a little bit more. If you step on these T's, you can break them you can easily do repairs, but always want to keep extra. You can get like packs, 25 couplings or 90s or T's. I know we here at the Waterwise Community Center have quite a bit of stuff on hand. We're constantly looking and trying to find any issues and doing any repairs. So here's an area that we retrofitted to drip irrigation. So I wanted to show how to look for a leak. So here is inline tubing. So when you do covered in mulch, it does give a little bit of, it makes it a little harder to find the leaks, but here we found a leak. So doing a repair, just simply cut out the part that was leaking. I just put a coupling in there. So I found the leak. You could just use those cutters, just cut out again the part that you need. So here's the parts I used to make my So here is the parts that I'm using. So I have couplings. I have, so this is a Rainbird tool where you can snap in your fitting. It kind of helps you out a little bit to get the drip parts in because it is a little bit hard to get in. Here's those cutters again, mini sledgehammer, and a couple of staples.
With drip irrigation, especially when it's covered by mulch, it might be a little tricky to find a leak. So the first thing we want to do is when we know we have a troubled area is pull back the mulch with a rake. And it seems like we found a pretty clean break right here. So tools that we'll need for the job is some insert couplings, some staples, a mini sledgehammer, and a cutter. So taking our insert tool, we put the coupling into the tear, make sure it's pushed in all the way, and then simply put the two pieces of pipe together, wiggling back and forth, make sure it's nice and tight. And to make sure that this is going to stay, we want to put a staple in with our mini sledge, hit it till it's nice and firm, not too tight to pinch the tubing. Once we're satisfied that the leak is mended, go ahead and take your rake, cover the tubing back up with mulch, and everything is good.
There you go, quick little video on that. So ongoing maintenance, always want to make sure we flush our filters. This is something that over time, if you can go years without flushing it, we can get buildup. Emitters could be clogged. We can start to see some issues with plant material dying because our emitters are getting clogged. So it just causes a lot of issues. Again, another picture. So here's the filter. We want to make sure we pull it out. Here's another brand, Agrifem. They make a good quality drip components as well. Here's just their version of that same filter. So that's what this one kind of looks like. A little bulkier, but still the same thing. And we always want to have a flush at the end of our drip zones. So here we have a lateral line with the flush. So we want to flush out our entire zone at least twice a year, as well as cleaning out our drip filters. Seems like we're running a little long on time, so I'm going to go ahead and skip the quick break and just cover irrigation controllers really quick, and then we can get to questions and comments if we have any. It's like we have a couple. Okay, perfect. So just really quick, irrigation controller types. We have indoor and outdoor controllers. Indoor controllers are a little less expensive because they don't have the covering and the weatherproofing. But make sure if you're going to install irrigation controller outside, maybe on the outside of your building or in the back of your yard, make sure that it's an outdoor. Weather-based irrigation controllers, or we call WIBICs. They adjust local weather conditions, landscape conditions, irrigation types, and uses that information to come up with the irrigation schedule. Where the most common now, especially for residential over these last couple of years, is Wi-Fi enabled, which works great. So we have seven Wi-Fi controllers at our site here. We can access it on any mobile device, on my computer now, adjust irrigation schedules, turn things on while I'm out there walking and like, hey, this kind of looks a little dry. I could just access my phone. So in our area, there's rebates available of about $80 towards getting one of these irrigation controllers. And it pretty much offsets the price pretty close. So the last thing is just repairs with irrigation controllers. This is a pretty nasty one. So check the obvious. Times where I have missed obvious things with the irrigation controller over these years. You want to check and make sure it's plugged in. Most of these controllers have a backup battery, usually a 9-volt battery, which will keep the time and the program set. So even though there is no AC power, if the power is out, the breaker's out, it's just not plugged in, it'll still give you the time and keep the programs, but it won't run the valves. So it might be a little tricky. Even though you don't have power, it'll look like it has power. Fuses, older controllers have fuses. If the fuse has popped, the irrigation won't run. You want to verify that you have power to it and check the terminals. So again, here's the multimeter. So what we can use with the multimeter is to check and see if we have power coming in from the main power source. So either plugged into the wall or if it's wired in directly, we can check that. We can check the voltage. This is the terminal strip here. We can check and make sure the irrigation controller is sending the power to the correct zone, or to the correct wires, to the correct irrigation valves. And I brought this up briefly, but wire nuts, the proper wire nuts are key. So you always want to use weatherproof. So they have a gel inside or electrical grease to keep moisture from getting into these wiring. So here, these are indoor wires, which people will have lying around. It does the job of connecting the two wires when you twist the wires in. However, it does not protect from water getting in there. Just like our cars, you'll see our batteries will get all that residue and build up. It'll not allow our battery to start our car. Same thing happens in the field, just at a quicker pace, because this is constantly in the moist environment. So using the voltmeter, we can check our AC voltage. Another thing, how we checked our control or our solenoids, we checked to see if our ohm reading or voltage was the same or was in the proper range. You can do that at the controller without having to go to your valves. You simply go to where the common is. So this says COM, so that's for our common. We stick one of our leads in there. And then with the other lead from our meter, we just go into each one. I could stick my other lead into zone 1, and it'll give me a reading. I could stick it into zone 2, zone 3, 4. So I can check the solenoids on every single valve on this controller, just right there, and I could see if there's any issues with any of my valves. You can pull them out or stick in the lead into the terminal strip here, or you can pull out to get a better contact if needed. But here's just an example here. So my multimeter, I stick one lead into the common and then one into my zone 1, and that'll give me a reading if my solenoid is good or if my solenoid is faulty. So I had a reading of 26.1 ohms. Again, anything between 15 to 100, you're typically good. There's just an example of that. You can use this to check your power. So going into where the plug goes into the bottom part of your transformer, located inside your controller, you should have about 105 to 229 volts. So the nominal voltage you want there is 120. So that's your standard outlet power. And then coming out of the transformer, it needs to drop it down to around 24 volts. That's what your irrigation system uses. It doesn't use a straight 120 volts. The transformer needs to drop it down. Transformers don't typically go out. And with that, that's all I have. So I had a couple questions. So I'm gonna take a couple minutes, and if you have any questions, actually, I have my closing poll. So if you could just go ahead and do this last poll really quick, and then we'll get to questions, comments, and I'll stay until we answer all of them. Thank you all for logging in today, and thank you for doing this poll. It's been great, and please stay if you have any questions or any, and I'll make sure we get to all of them. Okay, I'm gonna leave the poll up, but I'm gonna go ahead and get into these. Okay, I got a couple of great questions. Okay, so I'm gonna go ahead and start on the chat. So it says, can you please recommend a drip irrigation brand? Can they, the part mix use? Okay, yeah, so I mean, all the companies now have gotten into the drip. We use Rainbird. Um, Rainbird's pretty available. NetFM, AgraFem, um, even Hunter, like I said, Toro. Those are like the big brands, but really the key is finding parts that are available to you. So if you want a higher quality, big box stores do have parts available, but local irrigation warehouses, they have like an array of high quality drip components. I think the website is DripWorks. They have a ton of drip that you can order. Drip Depot is another one where you can look at reviews. You can look at tons of things. Okay, going on to the next one. So hopefully that helped. Lynn is asking how to figure runtime on drip using 1 gallon per hour emitters to equal 1 inch of water per week. Okay, that's a good question. There's a calculation. If you want to give me your email, if you're still on here, Lynn, or if you want to send me an email, I have some charts and I have some. There's a little bit more involved. Just to equal 1 inch with 1 gallon, that's a pretty simple equation. But but there's also some more that can go into that, like different plant sizes, plant canopy, if you're doing just single emitters, or if it's a drip grid with like an inline drip like NetFM. If yeah, so if you want to, okay, thank you for putting that in the chat. Okay, I'll write that down and I'll send you an email with what I think would be a good answer to that, and just kind of what I have. But it just takes a little bit of calculation. So we can absolutely do that. Okay. I have one quick question. If yeah, so all the webinars are available for you to access, and the PDF will be on our website. So it's at cbwcd.org/presentations. That's where you'll find a PowerPoint, a PDF of this, and then cbwcd.org/YouTube. That'll send you directly to our YouTube channel with all of our workshops that we've done. Yeah. Okay. Now let's see. Can you talk about gray water irrigation systems? Yeah. Gray water irrigation systems are viable in a sense. For really good resources on that, you can look at Gray Water Action, which is local. I think they're based out of Pasadena, if you're local to our area down here in Southern California. And they have a lot of information and workshops. As far as, is that going to have like eliminate the need for your irrigation system? Probably not. One of the easiest ways to do gray water system, in my opinion, is going into, it's called laundry to landscape. So you can buy conversion kits where there's already a pump that pumps out your washer, your clothes washer. So it's a conversion kit to convert that into an irrigation system, depending on how frequently you wash your clothes. That might supplement a little bit, but I wouldn't run that into an irrigation or a drip irrigation system because of clogging. But as a tool to help combat the larger issues of high demand of water use in our landscape, gray water systems, if you are enthusiastic about it, I completely agree that it'll be beneficial, somewhat beneficial, absolutely. But definitely look into gray water action. They are way more knowledgeable than I am on that. And I think the last one we have is, what are your recommendations on where and what advantages there are for drip versus rotating sprinkler systems? Yeah, Samantha, absolutely. So it all really, it depends, right? That's like the question or the answer you didn't want, but it absolutely depends. Drip irrigation is great. Rotating sprinklers are great. Here at the demonstration garden, we have a big mixture of both. And areas that have high traffic, or depending on the planting type, if you're doing a more sparse planting, meaning, they're not super, it's not a very dense planting, it's more spread out, drip irrigation tends to work a lot better. We install drip irrigation in a grid system, meaning every 18 inches, we have a row. So it covers the total soil area so that we do get that even distribution as if we had overhead spray. Although some areas, some of the plants don't necessarily like that. Some natives like overhead sprays as opposed to drip, because natives don't like to have what we call soggy feet. They don't like to sit in water and wet soil. So an overhead spray kind of helps, and it also helps push, leaches a little bit of the built up salinity in the soil and helps kind of push it down a little bit, where you don't really get that as much with drip irrigation. So it all depends. If you have a turf area, turf areas I have seen done with drip irrigation underneath, but you do run into issues. Done properly, they both are very viable. If you are local, and within the next couple weeks, we will be opening our garden back up, and we will be open on Saturdays. Either myself or Scott Kleinrock will be working on a Saturday. So if anyone comes in and has questions, so if you do have questions about irrigation, we'd love to kind of show you why we chose certain drip areas and certain overhead spray areas, and how the kind of process thought behind all that. But definitely something we're missing, not being able to do these in person. But yeah, hopefully that helps a little bit. But you can use either in almost any situation if they're done properly. Yeah. Okay, I don't think I have any more questions. So if anybody has any other questions, you have my email here. I'm writing down Lynn's email. I will be doing, I don't know if it's up yet, or if it's not, we will be putting it up soon on Eventbrite, but I will be doing a drip only, just focusing primarily on drip webinar. So it's about the same time. It's a little over 2 hours, and we just go over every aspect of drip. So hope to see you all there, especially if you're curious about drip. So with that, I will bid everyone a good weekend, and hopefully I will see you guys in the near future. Okay, bye. Have a good rest of your weekend.